Algebra 1 students, welcome to your notes on solving equations with variables on both sides. So today we're going to work with exactly what it says. Your problems are going to have variables on both sides of the equation. And don't let that freak you out. You can handle it. It says to solve equations with variables on both sides, you can use the properties of equality and inverse operations to write a series of simpler equivalent equations. So it really doesn't matter if you want to move your variable term from the left to the right, or if you want to move your variable term from the right to the left. That doesn't matter, but you really need to, your first step needs to be to try to get the variables on the same side. So what I'm going to do is I'm going to go ahead and move my variable from the left to the right here. So I'm going to use the subtraction property of equality. I'm going to subtract 8x on both sides of the equation. When I do that, I end up with a negative 4x minus 24. When I've done that over here on this right-hand side, I end up with a 0. Okay? My next step is I'm going to take that 24 and I'm going to move it over here to the right-hand side of the equation. So I would have negative 4x is equal to 24. Now I can divide both sides by a negative 4 using the division property of equality, and x is equal to a negative 6. Okay? The other, kind of the big idea, and one of the things I try to impress upon the Algebra 1 students as you take my class is if you leave my class and you understand one thing, it should be to isolate the variable. And we're gonna use that terminology, or we're gonna use that phrase. If you leave my class and you understand one thing, we're gonna use that quite a bit all school year because it encompasses quite a bit of Algebra 1. So take that for what you will. Okay, so on this particular problem, I'm gonna move my variable term, okay, over to the right. Just to show you that it doesn't matter which direction you want to go. You can take the variable term and move it either way. So I'm going to use the addition property of equality to move my variable term from the left to the right. Okay, and the reason I'm going to use a positive 4x is because I already have a negative 4x sitting there. So after I've done that, my variable term on this side of the equation cancels out, so I have 6 is equal to whatever I end up with over here. So now I've got 7x minus 8. All right, so I'm going to take this negative 8 and I'm going to move it over to the right-hand side by using the addition property of equality. I'm just doing whatever the opposite of that action is. So 6 plus 8 is 14. My 7x is still sitting there. Okay, now I've got 7 multiplied with x, and the opposite of multiplication is division, so I'm going to use the division property of equality to divide both sides by 7, and I end up with 2 is equal to x. And the reflexive property says that I could go ahead and write it this way if I wanted to. If it really bothers you to write it this way, I would be fine if you would say 2 is equal to x and be done. I have isolated my variable, I am done, but a lot of you, it really bothers you for some reason to have that x on the right-hand side of the equation, and so if you would like to, go ahead and put that on the left-hand side of the equation. Doesn't matter to me. Okay, moving on to 3 and 4. Okay, so these look a little bit different, and we're going to notice right off the bat that we've got some distribution that's going to occur in these areas here. Not a big deal. You guys should be pretty good at when you see these parentheses and nothing in between right there, you should know there's an invisible multiplication sign there. And that triggers us to go ahead and say, okay, I'm going to multiply that 4 with both of the terms inside of there. So let's go ahead and just copy down this left-hand side of the equation. And I've got 4 multiplied with 2, which is 8, and 4 multiplied with a negative x, which is a negative 4x. Okay? Now, my problem looks exactly like it has been on the other ones. So on this one, I'm going to go ahead and move my negative 4x, I'm going to move that over here to the left. So I'm just going to say the addition property of equality says I can add 4x on both sides of the equation. That causes these here to disappear. I've got 7x minus 7 over there now, and I've got an 8 left over on that right-hand side. I can move that negative 7 over here to the right by using the addition property of equality. So I've got 7x is equal to 7 plus 8 is 15. Okay, and some of you might start looking at this right now and say, that's not going to work out very nicely. And that is okay. You can use the division property of equality. I've got multiplication going on right there. So that means that the opposite of multiplication is division. If I divide both sides by a 7, I've got x is equal to 15 divided by 7, which is a fraction. And I can actually leave that as my answer. I don't need to do anything else with that. Some of you are like, Mr. Bear, I need to get a calculator out and figure out what that is. You're wasting time. I don't care what the crazy old decimal is that you're going to come up with for that. All right, so let's move on to number 4. Okay, obviously we already talked about that. The fact that should trigger you to go ahead and distribute. So I would have 6x minus 15 on that left-hand side. I would have 5x plus 20 on that right-hand side after I did distribution on both sides, because that's what those parentheses tell me to do. Okay, I still need to go ahead and isolate my variable. So on this one, I'm going to go ahead and move that 5x over here to this side by using the subtraction property of equality. That gives me x minus 15 is equal to, the 5's are canceled, the 5x are canceled out over there, so I've just got a positive 20 sitting there. Okay, how am I doing on time? I've got 6:54. Okay, I can add 15 to both sides of my equation using the addition property of equality, and I would get x is equal to 35. Done-zo. All right, let's go ahead and move on to number 5. Okay, and this says to go ahead and do number 5 on your own. So if we were in class, we would have you do this problem and put your pencil down and stand up when you're done. So I want you to actually do that. When you're done with this problem, I want you to put your pencil down and stand up, and don't touch your pencil while you're checking your answer for fact checking. I'll be right back. All right, hands up. Hopefully you did not use your pencil to fact check that answer. You should have gotten x is negative 23. Okay, so let's move on to number 6. Okay, so I'm going to go ahead and move my variable term here. I'm going to go ahead and move it over this direction this time. Again, it doesn't matter, whichever way you're comfortable doing, and it might depend on the problem you're working. Okay, so I'm going to use the addition property of equality. So now I've got 6 is equal to 6x minus 12. I want to get that variable all by itself, and so I'm going to go ahead and add 12 to both sides of the equation to get rid of these 12s over here. Okay, I end up with 18 is equal to 6x. I've got an invisible multiplication sign going on right between there, so I'm going to use the division property of equality, and I end up with 3 is equal to x. Again, like we discussed, you can be done right there. All right, so for number 7, we have a business problem. And if you would like, you can go ahead and pause the video. If it would help you to pause the video and read through this before I read through it with you, that would be totally cool. I'm going to go ahead and start reading. It says, Dan Druff, don't make fun of my bald head. That's not a spot for bald jokes. Okay, Dan Druff is vacationing in Chicago. He wants to visit the Willis Tower and needs to take a taxi cab to get there. Yellow cabs charge $3 plus 50 cents per mile. Orange cabs charge $5 plus 25 cents per mile. At what distance would Dan be charged the same amount by either type of cab? Okay, so what I'm going to do is I'm going to go ahead and show you the equation that I would come up with for yellow cabs. This is one of your overarching standards in Algebra 1 too, by the way, is you need to be able to take a real life situation and write an algebraic expression or an algebraic equation from it. So this is going to be something that we do quite a bit in Algebra 1, just so that you're aware. All right, so for yellow cabs, okay, I would write the equation of 0.5 m, or 50 cents per mile, so it's 50 cents multiplied by the miles, plus the $3 charge just to show up, okay? And so one of the things that you can do is you can say, okay, well, I'm going to analyze this last sentence of my question, and it says, at what distance would Dan be charged the same? So I know I'm going to use miles because it said what distance, and they gave me miles in the price there. Okay, so what I want you to do is right now, I want you to pause the video, and I want you to come up with the equation for orange cabs. Okay, and now that I've helped you come up with the equation for yellow cabs, it might be kind of a good place for you to figure out how to write an equation with a real life situation. So pause the video right now, and then when you come back, I want a hand check. I want to make sure you don't have a pencil in your hand so that you are checking correctly. Okay, pause. Okay, hopefully you actually do not have a pencil in your hand. There's my stylus that I used to write. I am done with mine, and so I'm going to put it down and check without anything in my hands, and I got it right. Good for me. Okay, so in order to find out at what distance they're going to be charged the same amount, we're going to actually set these two cab companies equal to each other. All right, and when I write this out, I'm not going to write the decimal form. I'm going to write the fractional form. So I'm going to say yellow cabs are 50 cents per mile, or 0.5 could be 1/2 plus 3. I'm going to write it like that. And I'm going to say that orange cabs are 1/4 multiplied by miles plus 5. And now this might start to look to you like some of the problems that we've been doing already today. All right, so I'm going to start by moving my variable term. I'm going to move my variable term over to the left-hand side by subtracting 1/4 m on both sides. All right. When I subtract, I need to make a common denominator. So this would really be a common denominator. This would really be 2/4 minus 1/4, or 1/4. So I've got 1/4 m plus 3 is equal to 5. Okay. I can subtract 3 on both sides, and I would end up with 1/4 m is equal to 2. Okay, and then this should look kind of like some of the stuff we did on the previous, why am I using a 2 right there? On the previous lesson. I'm going to pause so you don't have to listen to this commercial. All right, sorry about that. I have Pandora on in the background, and obviously sometimes to listen to free Pandora, you have to listen to ads. Okay, so I'm going to multiply on both sides of the equation using the multiplication property of equality, and I'm intentionally picking the number that I have in the denominator right there. Okay, so whatever's in that denominator, I can multiply on both sides, and that'll cause a situation where those denominators cancel out. Okay, so I would end up with m is equal to 8. And in this particular problem, I need to go ahead and answer the question. So I'm going to say at 8 miles, the cabs will be the same price. Okay, so I made a statement. At 8 miles, the cabs would be the same price. I answer the question: at what distance would Dan be charged the same amount by either type of cab company? And the reason why that is an important business question is my extension question for today. All right, and so I guarantee you that your quiz problem will be something more similar to this. What company would I pick if I was trying to be thrifty and I needed to go 15 miles to get to my destination? Okay, so I hope you would be able to use this information to know, okay, well, at that break point, one of these companies is going to be cheaper than the other, and now I would know how to figure that out. Okay, so thank you very much, folks. We'll see you in class.